Okay, nice one. Just recording that. Almost like I tried. Okay, so absolutely flustered. Going to look at one of the ways. So we were working with the sine and cos rules and a wee bit of tan the other night, where they were in when they were in that sort of format. Okay, and we were asked to solve for sine x or cos x. Okay, and we were looking at more than one answer. Okay, and that's the important thing. We were looking for more than one answer because of the way the sine graph and cos graphs are. Okay, if we pick a number on that y-axis and we come across, we're going to find two positions on the x-axis where we're going to meet that. Okay, so just throw down a wee quick example of that. If we've got our normal sine graph like that, and we say y equals 0.5, okay, and we get horizontal, then we're going to get two positions, okay, in which we can see an answer there, that we are going to get an answer. So that's what we were doing on Tuesday. Okay, so if anyone missed Tuesday, that might not make much sense, but hopefully we'll build on it, okay, and it'll come back. Okay, so as I said, I'm going to look at slightly different ways they can ask us these questions going forward. Okay, so one of the ways we can look at, okay, is it will ask you to find the coordinates. Of the points at which line y equals -1 intersects the graph y equals 5 sine x plus 1. Okay, now looking at that might be the first time we've seen something like that, but when we did straight lines, we thought about intersecting lines as well. Okay, so when do those lines both equal the same number on that y-axis? Okay, and when do those lines equal the same on the x-axis? It's the exact same type of question. Okay, we've got two equations there. We've got y equals -1, and we've got y equals 5 sine x plus 1. Okay, what we can do, instead of writing y equals, we can bring them both together. So we can say I'll start the other one up. We can say that 5 sine x plus 1 is equal to -1. Okay, so we've brought them both together. So instead of writing y equals -1 and y equals 5 sine x plus 1, we're writing 5 sine x plus 1 equals -1. Okay, so where do both of those lines give you the same answer for x? Okay, where do they intersect? Okay, once you've got it in that format, that's the type of question we were doing on Tuesday. That's the point at which we just start to rearrange. Okay, and then use our cast diagram and find x. So if we start that rearranging process, okay, first thing you want to do is get rid of any add or subtract. Move that to the other side, leaving you with 5 sine x. That'll give you -1, -1, 5 sine x. My 5s and my s's look very similar. Should have really picked a different number. And then we can move that 5 over. Oh. To get -2 over 5. Okay. Okay, so now we got to this point, and now it's important that we consider whether it's a positive or a negative. So remember, that's really important. So we're working with sine graph here. So sine is going to be positive. when we look at the graph, between 0 and 90, goes up to a peak. Between 90 and 180, it drops back to 0, and then it becomes negative from 180 to 360. Okay, so that's an important aspect. So that's where our answers are going to be. So because the sine x is equal a negative, our answers are going to be somewhere in that last two quadrants, in those last two quadrants. Okay, so if we split that sine graph into 90s, 0 to 90, that's our first quadrant, 90 to 180, our second quadrant, 180 to 270, our third quadrant, and 270 to 360, our fourth quadrant, then sine x is negative in our third and fourth quadrant. Okay, now that leads us into this cast diagram. Okay, we're 0 to 90, to 180, 270, and 360. Okay, so where is sine negative? That's what we're trying to think of. Okay, so sine isn't negative between, sine isn't negative between 0 and 90. Okay, it's positive if you look at the graph. Between 90 and 180, again, it's positive. But between 180 and 270, it's negative. So that's the first quadrant we're interested in. That's where our first answer is going to lie, between 180 and 270. And then our second answer is going to lie in between 270 and 360 because it's negative. Okay, sine graph is negative between 270 and 360. So again, we'll tick that. Okay, so when we find our answer, when we put sine x, or sorry, x equals sine to the negative 1, 2 over 5 into our calculator, we get our answer. Okay, that's going to lead us to doing a wee sum off the back of it. So remember, at this point, we don't write it as a negative. Okay, so from here to here, we forget it's a negative, and we're putting it in as calculator as sine to the negative 1, 2 over 5, and the 2 over 5 is always going to be positive. Okay, so in that bracket, it's always positive when we enter it into our calculator. Okay. And that's quite messy. Sometimes a wee bit something that can throw you. Okay, but you're looking to get x, in fact, in front of me, 23.58 degrees. Now that's not your answer. Okay, that's just the answer you're getting in the calculator. We have to then take it and put them into the third and fourth quadrants. Okay, so quadrant T, we're going to add on our answer there. Okay, so we're going to have 180 plus whatever we just found. Okay, so 180 plus 23.58 equals 203.58 degrees. Okay, then quadrant C is 360 minus x, and that's 360 minus 23.58. And that I can't do in my head. 336 degrees. Okay, remember, going back to that question. Okay, so that's the same format of question as we did on Tuesday. But going back to the start and looking at what the question was asking for us, it's asking for the coordinates of the points. All right, it's asking for the coordinate of the points at which they intersect. A coordinate, even when you're working with sine graph and the cos graphs, the coordinate is still going to be in the format x, y. Okay, so coordinates are always going to be in the format of x, y. So what have we just found? We found two x values, okay, and we get given that y value right at the start. All right. So the first coordinate is 203.58, comma, -1. Okay. And the second coordinate is 336.42. And again, that's to -1. Okay. Any questions, guys? Okay with that? I'm going to give you a couple to try. Okay. So if you have a wee go at find the coordinates of line y equals 3 intersecting y equals 4 tan x plus 1. Okay. So the second one, find the coordinates of y equals -2 and y equals 5 cos x -1. Okay. So you've ever go at finding the coordinates of those two, give that a wee bash over the next 5 minutes or so, okay? Let's have a wee look at this. Okay, so if that's not what I wanted to do. Hey, so you forget how to use things. There you go. Okay, first one, where those lines intersect. Okay, so we've got y equals 3, okay, which is just a horizontal line. We've got y equals 4 tan x plus 1. We're just bringing those together. 4 tan x plus 1 equals 3. Okay, solving that to leave us tan x. Okay, 3 minus 1, 4 tan x equals 2. Positive. Okay, so where's tan positive? In here. Okay, so putting that in a calculator. .6. Okay, so that's going to be one of our answers. Okay, so we're in that first quadrant between 0 and 90. So that's going to be one of our answers. Okay, that first quadrant, we don't do anything to it. Okay, the other quadrant we're in is that tan quadrant. Okay, so we'll say quad A, nothing happened. Nothing happens to our answer, 26.6. Quad T becomes 180 plus our answer, which is 206.6 degrees. And then putting that into coordinate form, well, that's going to be our x, and our y is going to be 3. That's going to be our x, and our y is going to be 3. Okay. If anyone's getting something different or I go too fast for you copying, give me a wee shout. Same again, bring them both together. 5 cos x minus 1 equals minus 2. 5 cos x equals minus 2 plus 1. Cos x equals 5 cos x equals minus 1. Okay. That negative sign tells us where we're going to go in our all sine tan cos. Okay. It being negative means I'll come back to that, Dylan, in 2 seconds. Okay. That being negative means I want to go in every quadrant where cos is negative. Okay, so that's between 90 and 180, which is our sine quadrant. Okay, and 180 and 270, which is our tan quadrant. Okay, so we're in both of them. Now the sine quadrant, quad S, is 180 minus our x, and our tan quadrant is 180 plus our x. Okay. Oh, never actually found x. So if I put that in my calculator, remember turning that into a positive to put it in my calculator, I'm going to spit out x equals shift cos 78.5. Okay, so 180 minus 78.5. Going to give me 101.5 and 180 plus 78.5. It's going to give me 258.5 degrees. Now finishing off, and please don't miss this point if this comes up in the exam, put it in coordinate form. Okay, so that's going to be your x answer. What was y? Minus 2. Okay. You're going to have 2 then.
Daniel, I never know which quad to, like, I don't know how to identify what quad to use properly. Like, I know is it no when say it was cos when it's positive on the graph?
Yep. Okay, so let's have a wee look at that. All right, because it's similar to the question Dylan asked as well. So that comes back to that. So this cast diagram. Okay, try and draw a nice straight line this time. So when I'm putting that in, C, the A, the S, and the T. Okay, and you can put 0, 90, 180, 270. My internet connection keeps doing that. Okay, you can put 0, 90 to show you that one quadrant. Okay, that 0 to 90 there that I've drawn on, that refers to the x-axis when we draw out these graphs. Okay, so remember that 0 to 90, 90 to 180, 180 to 270, 270 to 360. Okay, we'll do 360. Okay. How you identify them is when we get to this position here, all right, and we've got either cos x equals sin x equals or tan x equals. If it's positive or negative, it refers back to our graph, okay? So at that point it matters. So if we've got a positive for any of them, okay, then one of the answers has to be in 0 to 90, because all of those graphs are positive at the time. So cos x is going to be positive, sin x is going to be positive, and tan x is positive. Okay, if you were to draw those graphs out, and you went from 90 to 80, 180 on the x-axis, okay, that second quadrant, only sin is going to be positive. Cos x is negative, and tan x is negative. Okay. Likewise, in here between 180 and 270, only tan x is positive. The graph, cos x, which we know quite well, is negative, and sin x is negative. In between 270 and 360, don't know why I'm starting with tan now. Cos x is positive. Sin x is negative. Tan x is negative. All right. So because that was cos x equals a negative, I'm going to my quadrants where cos x is a negative. So cos x is negative in here between 90 and 180, and cos x is a negative in here between 180 and 270. Okay, so that's where my answers are going to be. Now, how do you get that answer when we find out the x term? Okay, when we solve the x, in between 0 and 90, nothing changes. Okay, so your answer in this quadrant is just going to be your x that you find out. Okay, in between 90 and 180, your answer is going to be 180 minus x. Okay, probably should have written that a bit neater. In between 180 and 270, when you get your answer at this point here, okay, in between 180 and 270, your final answer is going to be 180 plus x, and in between 270 and 360, your answer is going to be 360 minus x. Okay, so only in that first quadrant you don't do anything at all. All right. Does that make a wee bit more sense, Carly? Does that make a wee bit more sense?
Aye, thank you.
Is that all right? Did I answer your question as well, Dylan? Nice one. All right, so hopefully that clarifies it a wee bit. All right, so what I've just written out there compared to the actual graphs, okay, so I gave you printouts on Tuesday, which might help, okay? Those first two graphs that I gave you were just the sin x equals, all right, and the cos x, okay? So look at your milestones, those 0 to 90, 90 to 180, etc. Okay. Okay, so we rule that we can use to help solve in these questions, and we're going to do some past paper questions in the next 15-20 minutes or so, okay? But in the questions coming up, they're going to ask for a maximum, so it could be a maximum height or a maximum rotation, it could be a maximum something, okay? Now we can use a wee rule to solve that, okay? So if we've got, oops, not that. If we've just got the y equals sine x, for instance, and we are asked to find the maximum. So say find the max height of sine x. Okay. Now we know when we drew out sine x, okay, if I've got nothing in front of it, I've got nothing in front of the x, and I've not got anything added onto it, sine x, a normal sine x graph, is just 0, goes up to a maximum, cuts through at 180, and then hits 0 again at 360. Okay, that's our normal sine x. So if we were to find the maximum height, in the formula had sine x in it, maximum is going to be coordinate 90, and most importantly 1. Okay. So we can say max height is when y equals 1. Okay. So just bear that in mind. It'll come a wee bit more important soon. Okay. Likewise, we can do that for cos. So cos is going to have a maximum when we're at 0 and when we're at 360, but the maximum is still going to be 1. Okay. Same question. Find the maximum, and it could be height or it could be something else. Okay. If y equals 4 cos x plus 2. Okay. Now there's a wee bit more involved here. Okay, but there's 2 methods in which we could solve this. Okay, if you can sketch that, so you've got the skills to sketch that. So we know that that number in front of that cos is its amplitude. Okay, and we know that plus 2 afterwards. Okay, it's not in a bracket, so that is y-axis. Okay, so that's plus 2 in the y-axis when we're sketching that out. So if we were to sketch that out, okay, cost graph would look something like that. The maximum would be 6. Take that back. Look at that. The maximum would be 6, and the minimum would be -2. Okay. Now you can go back to when we did the sketching a couple of weeks ago. Okay, just to double check that what's happening there. Remember that 4 changes the amplitude. So if it was just 4 cos x, it would be maximum 4 down to -4 and back up to 4. But that plus 2 moves all our milestones up on the y-axis. That's why it goes to plus 6, down to -2, and back up to plus 6. Okay. Now there's another way we could do that, find the maximum for that. Okay. We can just substitute in where it says cos x, the number 1. So all that sum would be 4 times 1 plus 2. Okay, so that asked for, I'll write that out again so it's nice and neat. Okay, that asked for find the max. Where we see the cos x, okay, we can sub in the number 1 for cos x. So we would write out y equals 4 times 1 plus 2. So that would be a maximum. So you would have to state that in the question. Okay, so you would say cos x is at a maximum at 1. Okay, so just the cos x. We can lift out that cos x and just put in the number 1 in its place. We can also do that with the minimums. So if we were asked for the exact same question, but we were asked for a minimum, okay, so y equals 4 cos x plus 2, and we were asked to find the minimum. Okay, we know cos x is at a minimum at -1. Okay, so just the cos x graph, it reaches the bottom of the graph at -1. Okay, so we can substitute that in. To get that. Okay. Have a wee go at both ways yourself. Okay, so I'm going to say okay. So find the maximum and minimum values for that expression. Yeah, it is. Okay, so find the maximum and minimum values of that expression. Okay, using what I've just said. Okay, so you can do it in 2 methods. So try both methods because you have to sketch these graphs anyway. So sketch out 6 sine x minus 2. Sketch out 6 sine x minus 2, and then prove your answer by putting in, instead of sine x, the number 1, and instead of sine x, the number -1. Okay, have a wee go at that, and I'll come back on at 7 o'clock. Okay, makes sense. So max when sine x equals 1. Okay, so we're going to just substitute that in. So y would equal 6, 1 minus 2. So maximum would be 4. Okay. Minimum, we're going to, instead of sine x, we're going to have -1. Y would equal 6 times -1. We're taking away 2. So y would equal -8. Okay. So we're going to get a maximum at 4 and a minimum at -8. Okay. They don't have issues or get something different when they drew that out. We all good? Sweet. We got there. Okay, so this is one of those questions where, as I say, these sine and cos can be used to model repetition. So in this case, we've got a wind turbine. Okay, and these blades are spinning. They're just spinning in a circle. Okay, now we can apply a formula to that to measure the height of each tip of each blade. Okay, and the formula we're going to use is h for height equals 40 plus 23 cos x. Okay, remember that's 0. Sorry, x is greater than or equal to 0 or less than 360. It's just telling us the range. Okay, so don't worry too much about that. But that in front of us is just a standard sort of trig equation, but it's been put into a nice story. Okay, so just working through this. What's it asking for? Calculate the height of the tip of the blade after it's turned through an angle of 60 degrees. Okay, so that first part A. Now looking at that formula, okay, h equals 40 plus 23 cos x, that x is the degrees. Okay, so that 60 degrees is going to get substituted into that. So it's going to become 40 plus 23 cos x. Okay, now what's that degrees referring to? Well, we've got blade A, and that's our centre. Blade A going to rotate in that direction, and it's going to rotate through a 60-degree angle. Okay, that's what that means. So what height is the blade tip when it reaches this point? Okay, that's essentially what it's asking you to do. Okay, now you don't need to know that, but it likes to ask stories. So all part A is, I say all, but how many marks? Is that only worth 1 mark? Stingy. Okay, is h height equals 40 plus 23 cos x at x equals 60, so h equals 40 plus 23 cos 60. Okay, putting that in our calculator, you should get 51.5. Okay, and that's the height. Okay, so nothing different to what we've been doing. Okay, it's just a slightly different way of asking it. Part B is find the minimum height of the tip blade above the ground. Now we just looked at minimums. So when it asks for a minimum, we can, instead of writing cos x, we can write -1. Okay. So we've got h 40 plus 23 cos x. It's going to be a minimum when cos x is equal to -1. So we're going to substitute that in. H equals 40 plus 23 multiplied by -1. So h is equal to 40 minus 23. Okay, h is equal to, what does that give you, 17 meters. All right. So it's funny to look at the start, but it's actually not too bad. I say that. Okay, now we go to part C. Okay. Should have said, just take a wee note so you don't need to draw out the question. That's past paper 2017, paper 2. Okay, so past paper 2017, paper 2. And it's question 15. Okay, so past paper 2017, paper 2. And it's question 15. Okay, part C, calculate the values, so it's plural, so it's going to be 2 of them, of x, for which the blade tip A is 61 meters above the ground. Okay, so that's 61 meters is the height. Okay, so the formula h equals 40 plus 23 cos x, we're going to put the height in as 61 meters. So instead of that letter h, 61 is going to go in its place. Okay, And then we're going to find the values of x, just like we've been doing using that cast diagram. Okay. So when h is 61, so 61 equals 40 plus 23 cos x. Now, just because it's bigger numbers than what we've usually been working with, nothing changes. Okay, so we're solving for cos x. Now, I like to have my unknown, in this case, x. I like to have that on the left-hand side. Now, remember with that equal signs, we can just spin that round. Okay, so we're not changing any operation at this point. We're just spinning it round. So I'm just going to write the exact same equation out. Like that. Okay, and then we can solve it a wee bit easier, more easily. Okay, and we get to that point. Okay, so remember we're looking for multiple values. Okay, so we can go into our cast, and we're looking to see if this is negative or positive. It's positive, okay. So it's positive, cos x is positive in that fourth quadrant, and cos x is positive in that first quadrant. Okay, so between 0 and 90, and between 270 and 360. Okay, so our answer is going to be found in between 0 and 90, and it's going to be found in between 270 and 360. What am I getting? 24 degrees. Okay. We get x equals 24 degrees. Now I'm working in quad A, where x is just x. Okay. So I'm getting x equals 24. I'm working in quad C. X is equal to 30. Oh, sorry. I'm getting 360 minus x. My answer is going to be 360 minus 24. I'm getting an answer of 40.35. Okay, so I've got two answers. Remember what the question was? At what point is the tip of that blade at 61 meters? Now that's rotated round and round. Okay, the minimum we've figured out was 17 meters. Okay, that rotates up to a maximum as well. Okay, so we worked. You don't need to do this bit. This is just a wee proof. Okay, in my head. So I know the minimum that blade's going to go to is 17 meters above the ground. Work out the maximum is 63 meters above the ground. And the question was asking at what point will it hit 61 meters. That blade's going to hit 61 meters at that point and at that point. Okay, so that's going to spin round. It's going to reach 61 meters twice as it rotates. That's what the two answers are. Okay, so it's going to hit at 24 degrees. And it's going to hit again at 335 degrees. Closer in. Okay, so that's what that's modeling there, just that rotation. So it's modeling repetition. So that cost graph, we could go over and over and over again. Okay. Give me 2 seconds. I'll digest that. I'll try and get another one. Okay, nice one. So really similar. Okay, past paper. Don't know what that F stands for. So I think it's just a practice past paper. It's paper 2, so it's a calculate paper. Okay, and it's question 11. I'll find out what that F stands for. All right. So similar type question. We've got something that's rotating, going round and round. Okay, and there's going to be questions off the back of that. So someone's sitting in that, Emma. All right, and she's rotating. Her height again is h. Okay, and this time instead of the letter x, they've put in t. Now t is just the number of seconds since the start. Okay, now we're going to treat that the exact same as we treat x. Okay, so we're not going to treat it any differently than we treat x in that last question. Okay, so for question 8, for A even, h equals negative 31 cos t plus 33. Question A is asking what happens 20 seconds after the start. Okay, what height is she at? So we're looking for h, negative 31 cos 20 plus 33. And that just goes in the calculator. So negative 31 cos 20 plus 33 is 3.87 meters. Okay. Now the next part of the question, when will Emma first reach a height of 60 meters? Okay. So instead of the letter H this time, we're going to put in the height 60 meters, and we're going to solve the question like we used to solve for X, but they've just used that letter T. Okay, and T is going to refer to the seconds. So let's have a wee look, and we're just going to treat it the exact same as the way we treated X. Okay. H equals negative 31 cos t plus 33. We want to solve it when h is 60. Okay, and we're solving for t. And we're going to treat it the exact same as we treated x in the last question. Okay, for this, I want my unknowns on the left-hand side, so I'm going to spin that round. Exact same equation. Okay, and then I'm going to tidy it up. So negative 31 cos t equals you know what I could have done there actually. I'll just leave it like that. 60 minus 33. Okay, so negative 31 cos t equals 27. cos t. And I'm taking that negative 31 over. So it's going to be 27 divided by negative 31. Okay. So treating it the same, even because there's a t in there instead of an x, don't worry about that. All we're worried about is that negative sign. Okay. So we're going to go on our cast diagram and have a wee look. Okay. So cos is going to be negative. The cos graph is negative in between 90 and 180. Okay, so in between that quadrant and in between 180 and 270. So in that quadrant. Okay, so our answers are going to be 180 minus and 180 plus. So remember, we forget about that negative. Oops. And we're working out t. You're getting 29.43. Then we're working in quad S. Okay, so that's 180 minus 29.43. We're working in quad T. Minus T. We're working in quad T. It's 180 plus. Okay, it's 180 minus 29.43 is equal 150.57. Okay, and that's seconds. Now going back up to that question. Oops. They've actually split that up into B and C. Okay, so when will she first reach a height? So that's going to be the lowest time. And then when will she next be at that height? Okay, that's your second answer. 150 and 209 is your two answers there. Okay, but one was part B and one was part C. Okay, so that was your answer to B, and that was your answer to question C. Oh. Hey guys, I'm going to say let's take a wee break there. It's been about an hour we've been working. All right, so let's take just 15 minutes. So would that be past it? Okay, again, it's that repetition. Okay, so that spring is going up and down. Okay, up and down, and we can model it using that equation. So again, h is going to be our height, and t in this is going to be the time. Okay, now what's thrown in here is that value in front of the t. Now, you don't have to worry about that, essentially, until we get to the end and we need to sort it a wee bit. Okay, but it's nothing of concern, nothing too big to worry about. Okay, so we'll go through it. State the maximum value of h. So even though there's that 30 there, we can still do our cos x is the maximum at 1. Okay, so we can still swap in a maximum, okay, or the number 1, where that cos bracket 30t is. Okay, so we can just lift that out and substitute in the number 1 into that, and that will give us the maximum height there. Okay, so that's all they're looking for to do. Okay, so for h, 1.9 plus 0.3 cos 30t. Okay. Maximum when that cos 30t is equal to 1. Okay, now how is that the case when there's that 30 there? Okay, well, remember that number in front of the letter changes the phase. Okay, it changes how many waves, it doesn't change the amplitude. So it doesn't change the fact that the amplitude goes up and down. So we can swap that cos out and we put the maximum in. Okay, so h max is going to be 1.9 plus 0.3 times our 1. So it's 1.9 plus 0.3. H going to be 2.2 meters. Okay, that's it. See if they only give 1 point, it's usually quite a wee simple working like that. So we're simply lifting that cos 30t out, putting in the number 1. B, a little bit harder. Okay, and you can see that because it's worth 3 marks. Okay, calculate the height of the toy above the floor after 8 seconds. Starting with the same equation, and we're working out h. The t equals 8 seconds, that simply goes in, that's simply substituted in where that letter t is. And then it's a case of just putting it into a calculator. Okay, just putting that in as a calculator. Oops. It's 1.75 meters. Okay, so does that make sense? It's always good to check if it makes sense. Calculate the height of the toy above the floor after 8 seconds. Okay, well, the maximum was 2.2 meters. So having a height of 1.75, yeah, that sounds about right. All right, I don't need to know much more about that, but it's under the maximum. So if we got an answer like 1080, okay, then I'd go, right, well, that's not correct. Okay, so just double check the question and if it makes sense. That's when the stories are quite good. All right, if you get an outrageous answer, you can see quite simply, well, what it should be. Okay, last part of that question, part C. When is the height of the toy first 2.05 meters above the floor? Okay. So the fact it says when is it first means we're going to get a couple of answers out. So we're going to get to do that process when we're getting more than one answer. Okay, so the height was 2.05, I think. Just write out the equation. Uh, 2.05 equals 1.9 plus 30t. Okay, I'm going to spin it around, write out the exact same equation, but I'm putting my unknown over. Okay, and then I'm tidying that up. Uh, 0.6. Okay, now we've got positive at this point. Now the fact we didn't usually work with a number in this point, okay, that will throw a couple of people, and it probably would have thrown you if that came up with an exam. All right, but don't worry about that number until we need to solve right at the end for t. Okay, so I'm going to leave that 30 where it is. Okay, so don't try and take that away and make it disappear. Just leave that where it is. Okay, and we're just going to treat it the same as cos x equals something. Okay, so with that in mind, that right hand side is positive. Okay, it's cos, it's positive, so it's either going to be in this quadrant or this quadrant. Okay, so cos graph is positive between 0 and 90 and 270 and 360. Okay, now we can move it over. So 30t cos to -1. It's already positive, don't need to do anything there. So I'm going to get an answer for 30t out. So again, I've not moved that 30 over, not done anything with it, not worrying about it. What have I done wrong here? Sorry. Getting to that time of night. Go back to here, guys. It doesn't change some of the process, but 2.05 minus 1.9 equals 0.15, not 0.6. All right, so that just changes that. It changes that. All right, so 2.05, I took that as 2.5 and did it in my head. That's my fault. All right, 0.15. All right, sorry about that. And that in the calculator. 0.15 divided by 0.3 gives me an answer, thankfully. Oh, just 60. Okay, it gives me the answer 60. Okay. I'm going to take that answer and I'm going to put it into quad A. Okay, and the quad A stays the same, so 30t equals 60. And that means I can simplify it down now. Take that 30 across, get t equals 2. Okay. Quad C. 30t equals 360 minus 60 this time. So 30t equals 300. So t equals 300 over 30. T equals 10 seconds. Okay, so because that's on a spring, that makes sense. So what, say 205. So that's going to go from the bottom. It's going to reach 2.05 meters at 2 seconds. It's going to go up to the maximum and then it's going to come back down. And after 10 seconds, it's going to hit 2.05 again. Okay, so that sounds about right. Okay, now I think the question itself asked for first. All right, when's it first above it? So the first answer is 2 seconds. So that would be your final answer. All right, so just make it really clear that's the one you're using. Okay, so that was a wee bit tougher there just because there's that wee number or that 30 in front of that letter. Okay. Right. Here's the bad news. The next bit I'm going to go through, I would say, from my experience, it's probably the most hated bit of the course. To the point where some people just go, nah, not even chancing it. Okay, so it's going to be recorded. It's actually not as bad as you think, but it looks horrible when they ask it. Okay, so it looks a lot worse than it is, but because you have to remember a quite difficult formula, people don't like it. All right, but it's not as bad as it looks. It's called trig identities. Okay, so if you remember this from school or you've done it this year, okay, it's not that bad. These are questions where they want you to show or prove a relationship between sine, cos, and tan. Okay. It can also be used to simplify expressions. So they also like to show you, can you simplify this expression using these identities? Now, before we go into this, okay, just a quick note. When I write sine squared x like that, that means the exact same as sine x squared. All right, so that will become important later on. Likewise, now for this, you don't need to know about the graphs, you don't need to know about shapes, you're not worried about angles. You're just using something called substitution. So like we did when we were using simultaneous equations, when we're substituting in letters and numbers, and what we just did when we were substituting in t equals 8 seconds, when we seen the letter t, we put in that number 8. That sort of theory goes into this as well. Okay, now the relationships that you need to know, okay, these are the relationships you need to know. So relation and tan. These are not given. Okay, but you need to know to be able to do this. Is tan x equals sine x over cos x. Okay, that's equation 1. In equation 2, and there was only 2, There's only two relationships we need to know. Okay. Equation 2 is sine squared x plus cos squared x is equal to 1. Okay. Now that second one can be rearranged. So looking at the first one, all right. But that second one, sometimes you need to rearrange it. Okay, so sometimes it's not really obvious. Okay, when we do it, okay, it sometimes need to be rearranged. So that second one can also be written as sine squared x is equal to 1 minus cos squared x. Okay, all I've done there is move that cos term over to the right hand side. Or it can be written as cos squared x equals 1 minus sine squared x. And in that case, we're just moving the sine squared x over to the right hand side. Okay. So those two equations are all you need to know to be able to do this. Let's look at a question. Right, let's go. Example 1. Show that sin x times tan x is equal to sine squared x over cos x. Okay, so show that the left-hand side of that expression equals the right-hand side. So show or prove that sin x tan x can be rewritten in a different way, okay, by using the relationships that we just showed, and you can get to sine squared x over cos x. Okay, so that is my start. And that is what I'm trying to get to. Okay. I'm going to use those relationships that we wrote down. I'm going to substitute one of them into that left-hand side, and it's going to lead to the right-hand side. Okay. So I'm going to use the relationship that tan x is equal to sin x over cos x. And I'm going to substitute where I see tan x in that equation. I'm going to substitute in sin x over cos x. Okay. A lot of boxes going on there. So my start expression, sin x, tan x, sub in tan x equals sin x over cos x. So I'll end up with sin x multiplied by sin x over cos x. All right, so that's like we put a wee multiply in there. So if I've got sin x multiplied by sin x, that's going to give me sin x squared. Okay, so sin x multiplied by sin x is going to give me sin x squared. I can write like that over cos x, which is exactly where I want to be. So that's all I've done. That's proved that. So I've showed that using the relationship tan x equals sine x over cos x, sine x times tan x can equal sine squared x over cos x. Yeah. So that's been proven. Let's try another one, see if it makes more sense. Example 2. Show that. Okay, that means we're starting with whatever's on the left-hand side, and we're going to try and get the answer on the right-hand side. So show that 1 minus sine squared x over cos x is equal to cos x. Okay. So where the hell do we start with this? Well, we've got a relationship where sine squared x can be rearranged to have sine squared x in it. All right. So let's have a wee look at that relationship. So the relationship itself is sine squared x plus cos squared x is equal to 1. Now we can rearrange that to equal sine squared x equals 1 minus cos squared x. We're going to substitute 1 minus cos squared x into that first start equation wherever we see sine squared x. Okay, so I'm going to substitute that in. It's going to give me 1 minus, put it in a bracket, 1 minus cos squared over cos x. Okay, so I've gone from my start expression, I've substituted in a relationship, okay, and now I want to break that out, okay. So I've put that 1 minus cos squared x into a bracket there, okay. Now, if I break that bracket, I've got 1 minus 1, and that's going to be plus cos squared x over cos x. Those ones rule each other out, so 1 minus 1 is 0. Okay, so they disappear, and I'm just left with cos squared x over cos x. Okay. Now, cos squared x, remember, it's just cos x squared, so it's just cos x times cos x. Okay, so I can cancel one of those cos x's out and just leave myself with cos x. Okay, so I can write cos x squared as cos x multiplied by cos x over cos x. So one of those rule out, and I'm just left with cos x. Okay, don't need to do that line in the exam. Okay, don't need to do that. I'll put in a green box in the exam. Pretty horrible, but again, using one of the relationships, we've proved the left-hand side can be simplified down to equal that right-hand side. And there we go. Few more. I'll do as many as possible. Okay. Another way they can write it, but it means the same thing. Okay. It's been put in before as expand and simplify. Okay. And they give you sine x plus cos x squared. Okay. So expand and simplify sine x plus cos x bracket squared. Okay. Now we can rewrite that as that. Okay. Now remember, going all the way back to brackets, we do FOIL. Okay, so first terms multiply together. Okay, so sine x times sine x is sine x squared. Okay, so sine. Okay. Outside, so sine x multiplied by cos x. Inside, so we've got cos x, sine x. Okay, I'll just write it sine x, cos x. Same thing. Okay, and then the last terms, we've got cos x multiplied by cos x, which is going to give us cos squared x. Okay, we can tidy that up a wee bit. Okay, because there's two of those terms. Okay, then we want to look for a relationship. Okay, so the relationships we've got is tan x, okay, equals sine x over cos x. Now there's no tans in there, so that doesn't work. All right, we can't simplify using it that. Or we've got sine x, sine squared x plus cos squared x equals 1. All right, so if we rearrange that so that sine squared x and cos squared x are beside each other, we can substitute in okay. We can just substitute in number 1. Okay, so instead of this, we can write the number 1. Believe it or not, that's my answer. All right, you can see why people don't like these. I'll still copy. Give this one a wee try. Okay, so try this. Try show that. Okay. So try to prove that left-hand side equals that right-hand side. Okay, so give that a wee go for a couple of minutes, okay, up to about 1:15, okay, so I'll give you 3 minutes. Because I'm nice. Where are we going with that? Okay, so sin x, cos x, tan x. So I alluded to, we're looking at that tan x and we're using the relationship that we know about tan x. Okay, in the relationship, we know about tan x. It's the fact that it equals sin x over cos x. Okay, so we're going to substitute in sin x over cos x wherever we see tan x. Okay, so we're going to start with sin x, cos x, tan x, and then we're going to substitute in sin x over cos x. Okay. All that's telling me is sin x has been multiplied by cos x and it's been multiplied by sin x. Okay. Now what's going to happen now is that cos x, it just goes all above that cos x. Okay, so sin x and sin x is going to give me sin squared x. And then just cos x. It's all going to be over cos x. Okay. Just remember, when we're multiplying fractions, when we are multiplying fractions, we're just multiplying the top line and then multiplying all the bottom lines. Okay, so if it's just a whole number or just a whole term like sin x or cos x, okay, they just all stay in the top line. Another way we could have written them, sin x over 1, cos x over 1, but we don't write that. Okay. So they all just stay in the top line. So it's sin x multiplied by cos x multiplied by sin x. Last thing we do is those cos x's cancel out with each other. So it means we're just left with sin squared x. And that's our simplified answer. One more will take us up to past, then we can call it a night. In fact, just going back to that one. I hadn't pressed record last time, so it'll be a wee bit out of order. But if you watch this recording back, that's the answer to the question 2 back. Right. Last one of the night. Thank the Lord. Just say simplify. Simplify. You get tan squared x cos squared x. Okay, so we do have a relationship for cos squared x. Okay, cos squared x would equal 1 minus sine squared x, but that's not going to give us anything. That's not going to lead us anywhere. It's not going to help solve or simplify that. All right. So we're going to focus on this tan. Okay, we're going to focus on that tan. The tan squared x just means tan x times tan x. Okay, it's just done it twice. Okay, so if we say tan x is equal to sine x over cos x, we can then make the jump. Tan squared x is equal to sine squared x over cos squared x. Okay. Now that's the bit I'm going to substitute in. Okay, you could write that a longer way, where you break tan squared x into tan x times tan x. So you would have tan x times cos x squared as your sum. All right, and then you'd have sine x over cos x times sine x over cos x. And that's where that sine squared x over cos squared x comes from. Okay, if I substitute that in, formula, okay, and tidy up that top line. And I'll just cancel those out. Leave myself with that. Okay. Admittedly, not much simpler, but that's what they take as simplified. All right. Horrible. Takes a wee bit of practice and to get your head round. One of those ones that one day it just clicks. It just makes sense. Okay. But pretty damn horrible. Let's leave it there.
I know what you mean. Like, I think once you do get used to it, because the last few that we've done, I have got my head round it. So it is just like the more you do it, I think.
See, it's one of those ones that, see, if you just try them again, hide the answer, and then just try write it out again, and then just double check where you're going wrong or right. It will help. Let's have a wee look. In fact, I'll find some questions and I'll put a wee paper together for you when I send out my email tomorrow afternoon. All right. And see if we can get some of them done before Tuesday. Oh, sorry, we're off on Tuesday. All right.